this afternoon is our experiences around the world of working with partners on large-scale PV. For those of you who don't know Trina, hopefully you'll excuse me giving you a quick overview. Okay, so who are Trina? Well, we're a global top 5 photovoltaic company. Been around for over 16 years, which in manufacturing terms on large scale for PV makes us one of the veterans. We're listed on the New York Stock Exchange. In terms of business model, we're 9% owned by Chinese management, 91% actually floated on the stock exchange. In terms of what we can actually manufacture, well, if we had all of our machinery running 24/7, we could manufacture 2.4 gigawatts. I think in common with a lot of the other tier 1 manufacturers, we're currently running at about 2/3. Last year that meant 1.6 gigawatts in shipments and approximate turnover of about 1.3 billion US dollars. What does that mean in Europe? Well, of that 1.6 that was produced, about 1 gigawatt came into Europe, and of that 1 gigawatt, certainly 150 to 170 megawatts came into the UK. So there's a lot of our panels on roofs and in fields around the UK. Okay, so totally vertically integrated, as you would expect. You know, silicon arrives at one end of the factory. We've got a huge development in Changzhou. So silicon arrives at one end of the factory, panels come out the other end. So the upshot of that is that we've got complete control over the manufacturing process, and therefore it helps us from a quality perspective. Okay, we're a global footprint. Our main headquarters, like I say, is in China. We employ some 14,000 people around the world. In Europe, we're headquartered in Zurich. The first thing I'd like to talk about is maximising quality, and the reason why that's important in large scale. And the first thing that we need to do when we're considering large scale, and I'm sure you've heard a lot of this stuff today, these are just practical tips and tricks that we've picked up. The first thing that needs to be considered is the suitability. You know, what type of module is right for that environment. Things like I say, short-term reliability. What we mean by that is maybe 3 to 5 years. When it comes to product certifications, does it have its European mark? Does it meet the IEC standards? Does it meet MCS? If you work in other markets, does it meet their criteria, their standards? When it comes to the company that you're considering dealing with, obviously you need to look at their financial standing. You need to make sure that they're going to be around in years to come. But beyond that, particularly because this is driven by, most of the large scale is driven by investment money, it's very important that they're very sort of naturally risk averse. So therefore, there needs to be some investigation to make sure that the ISO standards are in place, both for manufacturing, environmental, health and safety. Do they have PV cycle in place? Do they have cradle-to-grave policies? So for what happens when these modules come to the end of their life. And then they need to consider performance. Certainly in Trina we've got various different modules for different environments. In the UK, obviously we suffer from low radiance in comparison to Southern Europe. So therefore it's important to look at the different technologies, and we have various different technologies to cope with that. Our honey poly would be a good example. That particular module had 2 world records in 2011 and again in 2012. Then we get into the long-term reliability in terms of being a partner, and that's where the number I've got to put up on here is our stock price, and our numbers are there for all to see. In common with a lot of manufacturers, we're losing money. We're just losing less than others. So the big push within Trina right now is to get ourselves back to profitability, so that we come out the other side of this consolidation, and therefore we're in a good position to support your projects going forward, whether that be from a warranty perspective, from a technical perspective, and just for us to be around in the long term, I think is going to be very, very important. Okay, so once you've done that initial assessment, the next thing is about looking at how can you optimise that design, because the best quality kit, poorly designed, won't work properly. I think we all know that. But then, because there are various links in this particular delivery chain, if you're the developer and you're handing it over to the EPC, it's absolutely vital that the EPC follows the design to the letter, so that you get an accuracy about the installation, and therefore you get the best result. There's some examples here, from European projects that we've been involved in. And I think one thing's for sure, each one of those has got both of those things in place. In fact, all three of those things in place. It's got the right products, it's been designed in an optimal way, and then it's been installed in a very accurate way. And therefore, it's no surprise when you see the actual performance ratios that you get out of some of these projects. Okay, so when it comes to actually looking at the development challenges and constraints that are in place to come up with good projects, there are some really sets that I think probably is well known. I'm not going to spend too much time on this, but it's about knowing what the obstacles are in advance, and then you can prepare, you can filter, so that you're not wasting your time on sites that are never going to happen. So it's it's looking at what the flood risk, it's looking at the environmental risk assessment, the comprehensive project with mitigation measures if it's going to be subject to flooding or anything like that. How far have you got to go to get to that DNO point? If you haven't, if these are the very quick checks that you can do that will rule sites in or out. I mean, I've seen, certainly in the UK, there's been a lot of people chasing lame ducks, projects that are never going to happen. And that's time, energy and money. So if you apply the right criteria, you rule projects out in or out very quickly. Okay, so moving on. So obviously we need to look at, let's say, territorial constraints. So we need to look at the land exposure, picking out the right modules, the right inverters. What's the slope? What's accessibility? Can you get a truck to site? When you want a coastal environment, you've got to be careful about saltness certificates, all that kind of thing. Geological assessment. What type of structure is going to work best for that particular array, for that particular geological structure. So, is it concrete? Is it better to be driven? Is it better to have a screw system? All of these things need to be considered very quickly. The type of things that you can come across, I know there's a site recently where they had World War II bombs were identified. So, these are everything has to be considered. And then you've also got to take into account the various stakeholders. So, is there a genuine economic benefit for the landowner and the plant operator? Does it satisfy both, or is it going to be a mismatched partnership? And then we've got public perception to overcome. And I think, today with the protesters outside kind of shows that we as an industry, as we get bigger, as we build more of these plants, we have to get better at doing that. About reaching out to the public and showing them. And there are many ways of doing that. It's certainly one of the best ways I've seen is actually engaging and employing local people. If you can just employ a number of people that have been on long-term unemployed, that will overcome a lot of issues. Just one idea. Okay, so without getting too technical about it, I'm a commercial guy rather than a technical guy. But when it comes to say for the final design challenges and constraints, once you've found the right site, very important that we then look at the tilt, the orientation, distance between rows, the acceptable shading losses. Are we what are you prepared to live with when you run your numbers? Does it make sense? And then finally, coming towards that ground coverage ratio, trying to look at that balance. And then if you've got any obstacles, any trees or buildings, wind turbines, etc., we need to have a solution for that. And then you're looking at the actual, obviously, the electrical layout optimization as well. Whether it's string inverters involving more cabling, or whether it's central inverters with less cabling, etc. Location of the inverter is very important. Okay, so future challenges. They're going to be, obviously we need to make sure that the feed-in tariff provision, number of ROCs that are granted, at least we have now a fairly clear view over the next 2 to 3 years. It's going to be about availability of suitable sites, proximity to the grid, etc. The fancy graph that I've got at the bottom of there, David mentioned about frequency, and that's really just shows you what they're doing in Germany in terms of flexing that frequency to allow more generation to be put onto the grid. That is one of the things that could be considered. I don't know how easy it would be to achieve, but it certainly has been successful in Germany. Okay, so I want to run through a few UK success stories, some of the partners that Trina have worked with. So here's one example with Lark Energy in Blackbush. It's a 3.3 megawatt array. It's a central inverter, power electronics. It's due south, 25-degree tilt, so quite optimal. Estimated PR was 79. Results so far 79.5. And it's surprising that virtually all of the projects that we've supplied, and it's not just because of the module, it's because of all the things that I've talked about, have actually come out with a better PR than estimated. On that particular project, there were some design challenges in terms of height restrictions, environmental impact, and that made things like mounting 4 modules in landscape, putting the inverter in the right place. There was a fixed height concrete house that had to be accommodated there to actually hold the central inverters. And then the environmental impact had to be, in that particular case, had to be something extra done to satisfy the local authority. And I think, again, that's something, again, when we're starting to do more and more and more of these fields, we are going to have to tackle that issue of satisfying the local authorities. There's many things that we can do, like reforestation, etc. Okay, another UK success story. This is with one of our key partners, Enesco, and this is Owls Lodge. This is one using some of our 72 cell modules. These are specifically for ground mount. Can be an advantage in terms of reducing the amount of ground mounted equipment that you need. Again, due south, 25-degree tilt. And in this particular one, what's interesting is that this is very heavily monitored. And I just wanted to share with you some of the results so far on that. Okay, so Enesco, they called the Enesco meter, gives out lots and lots of information without going to, I'm not here to sell the Enesco meter, but I'm really here just to give you a bit of information. And I think the key number is that one on the right, that the performance year to date was 123% of the design output. And so I think these assets, wherever they can be measured, it's a very useful thing. Okay, another one of Trina's key partners in the UK is Lightsource. We've done a lot of work with those guys and supplied a lot of modules. This one in particular is in Forley. It's actually known as a cabinet estate. It's a 5 megawatt array, and again this is the 72 cell modules, this time mounted end on end. And say due south again, 30 degrees in this particular case, and again, results here have been very encouraging. Just a few conclusions really, just takeaways perhaps, that this is, for us, the simplest way of approaching large scale. It's about, this is the way that you minimise your cost and maximise your return. So the bits that the information that we've picked up through a lot of experience all the way around Europe is that if you should use a structured methodology to identify viable sites, keep your costs down, because it's very easy to burn cash on projects that are never going to happen. Select the right products, but that's not just enough on its own. So it's, when I say the right products, we're talking about the panels, we're talking about the mounting structures, the inverters, etc. When you've made those selections and decided that you've got your supply chain in place and that they're the right partners, then it's about optimising that design and doing all the things that I spoke about earlier, and I'm sure the new guide will cover a lot of this as well. And then it's making sure that the installation is done in the optimal way. So you've got a great design, it has to be installed and compliant with that. And then finally, monitor the performance to ensure the greatest output and identify any particular faults. And in that way, you can learn from that particular project and take those learnings into the next project. That's it for me. Thank you very much.